Greetings, and thank you for joining us for another SANS ICS concept overview. I'm Don C. Weber of Cutaway Security and a certified SANS instructor. In this video, we will discuss using common tools to simulate industrial control systems that communicate using the Modbus protocol. We will cover how the ModbusPal simulator works and methods for enumerating the Modbus coils and registers. If you enjoy this video and the topics we cover in the SANS ICS concept overviews, be sure to like and subscribe to this channel. For this concept overview, we're going to be talking about Modbus and Modbus Enumeration. We're going to be using the ICS 410 Windows 10 system and also the Control Things Linux system as well, both of them being virtual machines. Modbus is a good industrial control protocol to talk about because it's used heavily throughout many sectors of industrial control systems, and it's also a really easy, well, it's a less complex protocol, and so it's easy for people to start with because you can break down the protocol into nice chunks for the learning process. If you want to know more about Modbus, as you can see here, I've got the Wikipedia pulled up. It's got a good description about the history of Modbus, where it came from, and the actual implementation as well. Modbus uses coils and registers to interact with information on a specific device. A coil is just a bit of information, and a register is 16 bits of information. So if you are just controlling something that's on or off, or you just need something to be true or false, then you would use a coil or discrete input. But if you have more complex operations, some type of analog, temperature, or something like that, you'll need more information, more than just a bit, and so you'll have to use a register. And so we'll be interacting with coils and registers as we're going through. Now I'm scrolling down through the Wikipedia page because the way we're going to be interacting with that is by leveraging the Modbus protocol and sending specific function codes with information with data that follows that. And as we can see here, interacting with the discrete inputs in the coils, we're going to be using function code 1 and 2. If we want to read from our registers, function codes 3 and 4, depending on which one that we want to interact with. But we can also, depending on the device's configuration, write to those areas. So if we want to write to a coil or multiple coils, we'll use function codes 5 and 15. Registers 6 and 16. And so it's important to understand when we're talking about the protocols, it's important to understand how that is actually implemented. And we'll see that used in some of the commands that we're about to do. Now, since I don't have an endpoint device, a lot of organizations will use what they call simulators. There are different simulators for different type of industrial protocols. For this one, we're going to be using one called ModbusPal. So if I'm in the Control Things VM, all I have to do is go to Activities and go into the search and start typing Modbus. And we can see that it comes up with ModbusPal. If I click on this, what it'll do is it's going to open up the application, as we can see here. Now this is written in Java. It's actually an older project. It was written on an older version of Java. We're leveraging the latest versions of Java on these systems, and unfortunately, because it's a deprecated project, in other words, nobody's actively recoding it, there are some display issues. So you're not going to see that here. Normally the Modbus port is going to be 502. We've modified it so that we don't have to run it with root privileges, so that the actual port that we're going to be interacting with is 10502. So you'll see that in just a second. Okay, so ModbusPal is just going to simulate an endpoint device. And what we've done here is we could add registers, we could add coils if we wanted to. We can add different points to it, but we've already done this for you. Okay, by clicking the load button, you can see here that we have a script, a voltage regulator script, and this is going to simulate. If I select that and click OK, this is going to configure ModbusPal to be a voltage regulator that you would find in any type of industrial control systems sector. Okay, these voltage regulators are used to control the current that's going to a specific type of device, whether it's an HMI or a human machine interface or a program logic controller. It's there to protect and only provide a specific amount of power to that device. So it's extremely important. If we modify this, potentially we could have damaging effects on that endpoint, which could cause physical issues within that process. So it's important that we maintain the security of this. As we can see here, we see that when we loaded the program, we got some extra items in here. If we click on this I right here, we can see that we have configured several things for the simulator. We're in the holding registers tab, so we have several holding registers that we've configured. We have an input voltage, which is the voltage that's going on right now with that device. Right now it's set to 0 because we haven't, it's not running, it's not serving up any voltage. And you'll see how we modify that in just a second. But our configuration settings, the things that our voltage regulator is set to, we can see here that its output voltage is configured for 120 volts, and that we have some safety constraints on this as well. We have a minimum output voltage of 110 and a maximum output voltage of 130, okay? Which is typical for most devices. You'll have parameters, limiting parameters that can be used to generate alarms or actually to keep the process within a specific range. So this is common for these types of devices. So these are our holding registers. If we click on the coils tab, we can see that we have 2 coils configured as well. And our tag names for these are enable output and also override maximum and min. All right. So in other words, if we want to the device to be active, we would set this to true. So if we turn this device on, it would actually activate and start providing power. We can basically disable this device by writing a false value to this, and that should turn it off. So I'm going to close this window for a second because I want to see this. I want to show you this automation. Okay, this automation is just it's been configured, and unfortunately we can't see it because of the display issues. But what we've done is we've added a sine generator to this to simulate the fluctuation of the voltage going through this device, so our input voltage. And this is going to be connected to that register. So if I hit this play right here, what will happen is the button will turn red, but if I go back and I look at my holding registers, we can see that this is changing. It's changing over time. The slight fluctuations, the variations that we will see associated with a voltage to these devices, and we can see that it's operating in the parameters that we've configured for it, which is what we intended. Okay, so now we have simulated a running voltage regulator within our process control networks. But what we're here to talk about is how enumerating and interacting with that device via Modbus is, how can we do that? So using our control things VM, I'm just going to go ahead and go to activities and open up a terminal. And let's reposition this. Okay, so now we can see this. All right, I've got a few commands. What I'm going to do is I'm going to use a tool that it's a Perl-based tool, and this is a little bit older tool as well. I don't think it's maintained anymore, but it's going to work for our purposes here. So Modbus Get, actually Modbus TCP Get. So I'm going to take this command, and right now we just I wanted to list out the help. And as we can see here, our Modbus Get command will read bits, read words, which are actually our registers, and so we can interact and query the information from the endpoint, in this case our voltage regulator. But we also have writing capabilities, so we can interact with that endpoint as well and modify those configuration settings. Let's go ahead and do that now. So let's read some coils. So I've already got a command here set up. So we have mbtget, our unit ID, which is just the identification for our specific device. In this case, our unit ID is 1, so I've already got that set up. Our service port, as I mentioned, is running on 10.502. 502 is the typical normal default port for Modbus, but we've just added a 10 in front of it. And then we want to R1, so read coil. So if we look back at our help, we can see that I want to read bits, and that's just reading from our coils. We're going to have a starting address, and then we're going to have the number of values, so 2. So A is our starting address, and then the number of bits that we want to read, in this case, is 2. We're also configuring this with the IP address of the device. So if I copy and paste that in here, actually what I want to do, let me clear my screen. So if I copy and paste that in here and I run this command, oh, connection failed. All right. So what happened is I didn't hit the run button. So over here on the run, so the service isn't listening at all. All right. So let's go ahead and click on run. You can see that it's slightly changed. This will not. When I first ran this, I thought that as soon as I clicked on run, this light would go green, and it's not. That's not what it is intended for. This little button right here, this grayed out button, what it's used for is to indicate traffic going to the port. So if we go back over to our terminal, I'm just going to up arrow and rerun that command. As you can see, we flashed green for just a second there. And what it did is that Modbus, the mbtget, queried those registers, and we can see that our first register is a 1, so a true value, and our second register is, or excuse me, our second coil is 0, so a false value. And that's the settings that we saw for our coils earlier. We can do the same thing for our registers. Let's copy and paste that command. Let me clear that. And this time, instead of running R1, I'm going to run R3. And we know that we have 4 registers. Okay, so if I hit enter on this, mbtget communicated with ModbusPal, and we saw the green light flash. And now we can see that we have information from our 4 registers. Our current voltage is 121, and then we can see all of our other configuration settings there. If I run the command again, we can see that the voltage has changed, but all of our configuration settings have stayed the same. So it's exactly what I expected. But this is all on a local host. I want to demonstrate that you can do this remotely from another system. So even though we're using an IP address, my ModbusPal is running on this system. Let's go ahead and do this example from a Windows system. So I'm going to go ahead and change my VM. And as you can see here, this is our Windows 10 VM, and I'm going to run some commands from here. And what I want to do that is I want to go ahead and start a command shell. Actually, I've installed the Windows terminal, so I'm going to run from the Windows terminal. I just prefer it. Okay. And what I'm going to do is I'm going to run some commands to interact with that endpoint. But I'm not going to use mbtget. Okay, so mbtget is a little bit older. It's deprecated. It works exactly as we need it in this case. But a little bit newer of a project is the rodbus client, and this is a Modbus client that is written in Rust. So it's a updated version of C code. It's a this client is actually provided by Adam Crane. It was written by Adam Crane and his team as a part of stepfunction.io, and you can find more information about it there. We'll include the link in the show notes. But it's just a more active version of this client. So I've added that to this Windows VM, and we're going to use that here. So I'm going to copy and paste this into our window. Oops. Double clicked on accident. And I'm going to run the help on here. And this is a Modbus client that is going to interact and communicate with our endpoint device. Okay, and as you can see here, the verbiage is slightly different. So we have read coils is going to be RC. If we want to read discrete inputs, it's going to be slightly different command. If we want to read our holding registers, RHR. All right, so help is very important when we're looking at this. We can also, because there are some specifics about each one of those subcommands. So let me clear this. So if I wanted to understand how to use the read coil command, I just type the RC, and now we can see that the RC is going to take a quantity and a starting address. So usually I'm going to start with the starting address. start at address 0 and then read a quantity of 2 like we did before. So that's what we did before. Let's go ahead and cut and paste this command in here. Hopefully, this one, the read coils. Hopefully this works correctly. And so as we mentioned, so Rodbus Client, I'm pointing to my host is my IP address and the port that we're running the Modbus service on. And then we have a starting address of 0 and a quantity of, we want 2 values. So we want to read 2 coils. And my expectation is that the first one should be true and the second one should be false. And that's what we have here. Our index 0, so coil 0, our first byte, or bit, excuse me, is going to be true, and the next one is false. So that's what I expected. And then I can do the same thing for reading holding registers. Which, like our Modbus mbtget, the same values came out here. So the first value is going to be variable, so that should change over time. Let's go ahead and check that out. Okay, we can see that it went, the first time we read it was 124, now it's 115, but all of our other values are the same. Okay, so now we're interacting, we're querying this information, and our management servers within our production environments, they're going to be doing the same thing. They're going to be gathering information from these devices. They're probably not going to be querying these values right here, the configuration values, but they definitely, if they need information from the voltage regulator, they're going to want to know what the current voltage is. But if those registers and coils are writable, if we can write to them from somewhere else, notice that I didn't have to do any type of authentication or anything like that. So if we want to turn off the power, if we want to write to one of our coils, we can go ahead and do that. So I'm going to take one of my Rodbus commands. So let's clear that. Now we can see here we have the client, or the name of the application. We're still talking to the same voltage regulator, but this time we're going to WSC. So we're going to write to a single coil, write single coil. Okay, we're going to do index 0, and I knew that by doing the help, and then we're going to set that value to false. Right now, index 0 is true. Okay, so I'm going to, you know what, let's actually, I'm going to run the coils command one more time. So here's our coil. So now we know it's set to true. I'm going to write single coil to false. The reason why I printed it out before is, as you can see, it doesn't give me a current state. I'm going to have to read those again. So let me go ahead and read those. My expectation is that it changed. That first value is false. Now remotely, from another system, I have basically turned off this voltage regulator. Okay, and this could have an impact on the process as a whole. If all of a sudden one of those endpoint devices that's managed by the voltage regulator, program logic controller, an HMI, human machine interface that our operators use to interact with it, now it's off, basically shutting down the power to that device. Right? It's not an ideal situation. Let's go ahead and change it back to true so we're not having an impact on the actual process. Now, we would want to do this in a test environment. We would not want to do this in a production environment. Even if we wanted to demonstrate risk, we'd still want to do it in a test environment. Now, we can also do the, let's go ahead and, oh, actually, I've already done this. I turned that back on, but I wanted to change the override, max override. So in other words, I want to interact with multiple coils. So write multiple coils, start value of 0, and then I have the individual bits that I want to set. So 1, 1, it's not an 11. I'm not sending them to 11. 0, bit 0, which is going to be this first bit, is going to be 1. I'm going to set that to 1. Then the second bit, it's actually, visually, it's the first one. But you read these bits from right to left. I'm going to set that to 1 as well. So let's go ahead and run that command. And as you can see, now I've set both values to true. All right, writing to, having an impact on the endpoint. All right, But it can get more dangerous than that. If we understand the physics that is involved with these devices, we can make modifications to those endpoints. When we're talking about power, we're talking about modifying the amount of power that's being delivered. If I make a change, if I want to change the max output voltage to 220, now I'm going to be supplying that device with more power than it's intended. If it's a US, it expects probably about 110 volts. If it's in Europe, more than likely it's expecting 220. Okay, let's clear this out. But if I've implemented this in the US, let's go ahead and read my holding registers, or let's read our holding registers one more time. We can see those values. Okay. But if I change that value to 220, and I read it again, now we can see that my maximum value is 220. In other words, if the voltage actually goes up above 130 like it had before, it would throw an alarm. So it was originally configured for 130. So if it started serving up 220 volts, it would most likely it would have shut down, but it also would have produced alerts. But if I want to change the voltage that it's providing to that endpoint, and I change that maximum value, then this device isn't going to throw any alerts whatsoever. So now I can come to my output voltage, max output voltage, and I can change that. Let's go ahead and read. Now I'm telling the device, not only is it safe, don't throw any alerts for when you go to 220 volts, now I'm telling it to go ahead and do 220 volts. Now, if this was an actual device, the simulator's not going to, it's not configured to actually jump up to those values. Okay, it's going to stay in the parameters that we configured for the simulator. But if this was an actual device in the field, it would start pushing out 220 volts. So that's what you would see here, and this would create a very dangerous safety situation that could have an impact on the process and unfortunately impact on the people helping to run the process. Okay. All right. One of the reasons why I wanted to show you Rodbus Client is it has some additional capabilities beyond what the mbtget has. And probably my favorite feature here is the polling feature. So as you can see, we have the normal command as we could expect. We have the H, which is defining our host. And we have the read holding registers starting at 0, quantity 4. All right, that's normal. But we also have this -P option, which is polling. And it's in milliseconds, so I give it a 2000. So every 2000 milliseconds, or 2 seconds, it's going to query that endpoint. Okay. So as we can see, our first value, it's set for 120. And then we can see them changing over time. I'm going to go ahead and stop it. I didn't have to do anything. I just set this polling up, and it went out and gathered that information, brought it back to me, and then I could potentially use that information and act upon it. Okay. I'm reading registers right now. What if I set this up to write to a register every 2 seconds? I think that would be, I could potentially keep resetting that device, either turning it off. Somebody goes and tries to turn it on, I turn it off. They turn it on, I turn it off through running this script. Okay, or I reset it, continuously resetting the output voltage to 220. That can definitely have a confusing impact on the operators. So I'm not necessarily showing this to you as an attack tool. I'm showing this to you as a tool that has capabilities to leverage Modbus to interact with the endpoint device, and some increased functionality. Some of the things I could have written this up in Python, Ruby, any type of scripting language. I could have done the same thing, but this tool comes with those capabilities already built into it. Okay. So from our concepts, let me go ahead and switch back over first to our simulator so I can talk about our simulator and what we've done. what we've talked about in this concept overview is using the industrial protocol Modbus, interacting with endpoints, understanding how to enumerate and make modification to those endpoints, and I've added some discussion around the impact this could have on your endpoint, on your process as well. Thank you for tuning in to another concept overview with the SANS ICS and Cutaway security teams. Please let us know if there are other topics you would like us to cover in the comments below. If you enjoyed the content, please be sure to like and subscribe to the SANS ICS YouTube channel. This has been Don C. Weber of Cutaway Security. Go forth and do good things.